Ever wondered how you can make science fun at home? Well, ponder no more. Today we're venturing into the realm of DIY science experiments that you can conduct right in your own kitchen, transforming it into a mini lab. We'll be exploring 3 fascinating experiments: crafting a homemade lava lamp, concocting rainbow milk, and growing your very own crystal tree. Each one is a thrilling adventure that marries the fun of DIY with the magic of science. Ready to dive into the world of science? Buckle up for our first experiment. So, how about making a lava lamp at home with simple household items? Imagine turning your kitchen into a mini science lab, and the experiment of the day is creating a groovy homemade lava lamp. All you need are a few simple ingredients: oil, water, food coloring, and effervescent tablets. Let's dive right into the process. To kick things off, fill up a clear, empty container about 3/4 full with oil. Next, fill the rest of the container with water. You'll notice that the water sinks to the bottom, creating 2 distinct layers. This separation occurs due to a fundamental scientific principle: density. Simply put, water is denser than oil, which means it packs more mass into the same volume and thus sinks to the bottom. Now let's add some color to our experiment. Squirt a few drops of your favorite food coloring into the container. Food coloring is water-based, so it will sink and mix with the water layer, leaving the oil layer untouched. Next, we introduce the effervescent tablets. These tablets contain substances that react to form gas when they come into contact with water. Break the tablet into a few pieces and drop them into the container. Watch as they sink down and start to fizz, creating gas bubbles that rise through the oil. As these gas-filled water droplets reach the surface and the gas escapes, the denser water droplets sink back down, creating a mesmerizing lava lamp effect. Now you might be wondering why the water and oil don't mix, or why the food coloring only mixes with the water. The answer lies in the molecular structure of these substances. Water molecules are polar, meaning they have a positive and negative end, while oil molecules are nonpolar. This difference causes the water to bond with other water molecules, and similarly for oil, but not with each other. The food coloring, being water-based and polar, follows suit and mixes with the water. And that's how you create a colorful spectacle right at your kitchen table. But don't stop there. Our next experiment is even more exciting. Remember how we talked about density in our last experiment? Well, get ready to see it in action in a whole new way with our rainbow milk experiment. Now, this experiment is a fantastic way to visualize some interesting scientific principles using just a few household items. All you'll need is a shallow dish or plate, some milk, whole or 2% works best because of the higher fat content, different colors of food coloring, and a little bit of dish soap. First, pour enough milk into the dish to cover the bottom. Then drop different colors of food coloring into the milk. Try to space them out and use a variety of colors for the best effect. Now here's where the magic happens. Dip a cotton swab or the corner of a paper towel into some dish soap, then gently touch the surface of the milk with it. What you'll see next is a burst of color as the food coloring races across the surface of the milk. But why does this happen? It's all down to the science of molecules. Milk is made up of water, vitamins, minerals, proteins, and fat molecules. Dish soap, on the other hand, is a surfactant, which means it's good at breaking down fats and proteins. When you add the dish soap to the milk, it rushes in to break up the fat molecules. As it does this, it carries along with it the food coloring, creating a swirling rainbow of colors. This is a fantastic illustration of how dish soap works to clean greasy dishes, breaking up the fats and lifting them away. Another key factor here is surface tension. Milk has a high surface tension, so the food coloring floats on the surface until the soap comes along. The soap reduces the surface tension, allowing the food coloring to mix with the milk and create these beautiful patterns. This experiment is a great way to introduce kids to the concepts of molecular bonds, surface tension, and chemical reactions in a fun and engaging way. It's also a reminder of the fascinating science that's happening all around us, even in something as simple as washing the dishes. Isn't it fascinating how everyday items can create such a colorful display? But wait, there's more to come. Our final experiment is going to be a real showstopper. Ever wanted to grow your own tree, a crystal tree that is? Let's explore how to do that. Embarking on this journey to grow a crystal tree, you'll need a few household items: cardboard, table salt, Mrs. Stewart's bluing, water, and a dash of ammonia. But before we dive in, let's set the stage with a bit of science talk. Crystals are a fascinating aspect of nature, a visual spectacle of what happens when certain substances dissolve in water and then are allowed to evaporate. This process, known as crystallization, transforms a solution into a solid form with a unique, often mesmerizing geometric pattern. This crystal tree experiment is a fun and simple way to observe this process right at home. First, you'll need to fashion a tree out of your cardboard. It can be as simple or as intricate as you want, though the more branches you have, the more places for crystals to grow. Once your tree is cut out, stand it up in a shallow dish. Now let's get to the magic potion. In a separate container, mix together equal parts of water, bluing, and salt. Add a few drops of ammonia to the mix. The bluing, a laundry product, has a unique property that allows it to remain suspended in the solution rather than sinking to the bottom. This is key for the crystal growth. Pour your magic potion into the dish around the base of your tree, but not directly onto it. The cardboard will absorb the liquid up into the branches. As the water in the solution begins to evaporate, the remaining substances have no place to go but to cling to the cardboard. And voila, you've set the stage for crystallization. But wait, where are the crystals? Patience, my friends. The real magic of growing a crystal tree happens over time. As the water continues to evaporate over the next several hours, the bluing and salt will slowly start to form crystals, creating a frosty, sparkling spectacle right before your eyes. Now, you may wonder why we added ammonia. Well, it helps speed up the evaporation process so you can see your crystal tree grow faster. It's like giving your tree a little science-based growth spurt. And there you have it. A step-by-step guide to growing your own crystal tree. You'll observe firsthand the fascinating process of crystallization, transforming a simple piece of cardboard into a glistening spectacle of science. And the best part? You can do this over and over again, creating forests of crystal trees, each unique in its own way. So why not give it a try? Turn your kitchen into a mini science lab and explore the magic of crystals. It's a fun, hands-on way to understand scientific principles, not to mention it results in a pretty cool piece of homemade decor. And there you have it, your very own crystal tree grown right at home. Isn't science fantastic? Oh, well, that was quite a journey, wasn't it? Now, who said science can't be fun? We've just explored 3 fascinating experiments that you can easily recreate at home using simple items you likely already have in your kitchen. First, we created our own homemade lava lamp. By mixing oil, water, food coloring, and effervescent tablets, we were able to observe the interplay of density and chemical reactions. The oil and water separated due to their different densities, and when the effervescent tablets were added, they created gas bubbles that traveled through the water and oil layers, mimicking the mesmerizing movements of a lava lamp. Next, we moved on to the rainbow milk experiment. This experiment demonstrated the effects of surface tension and the interaction of soap with fat molecules. By adding drops of different food coloring to milk and then adding a drop of soap, we saw a burst of color as the soap broke down the fat molecules in the milk, reducing the surface tension and causing the colors to mix. Lastly, we grew our own crystal tree. This experiment is a prime example of the process called crystallization. By creating a saturated solution of laundry bluing, table salt, and ammonia, and then soaking a cardboard cutout in it, we watched as the liquid traveled up the cardboard, evaporated, and left behind beautiful crystal formations. Each of these experiments not only provided a fun and engaging activity, but also gave us a hands-on way to learn about various scientific concepts. I encourage you all to try these at home and delve deeper into the science behind them. You'll find that there's much more to discover in each of these experiments, and who knows, you might even come up with some new ones of your own. Remember, science is everywhere, even in your kitchen. So keep experimenting, keep exploring, and most importantly, keep having fun with science.